Hi everyone, let's take some notes on today's lesson, which is lesson 10 from unit 5. And let's move over to the notes. Title of your notes 5.10, and this is going to be an example. So suppose that you're an astronomer and you're stargazing and you measure the distance to a star is this large number. And this large number here, you can count the number of zeros, but it has 14 zeros. So when you write that down on your notes, make sure you count out 3, 6, 9, 12, 14 zeros. That's 100 trillion miles away you discover this star. Then you discover another star that is 1 million times the distance away from that star. So you have 100 trillion times a million. So even if this dot was 100 trillion, then I would need 1 million dots. 4, 5, 6, 7, 8, 9, 10. Okay, that's 10. Now I just need 1 million of those dots away. That's how far. So this picture is definitely not to scale because, as you can see, this is not 1 million times away. But just imagine. I mean, if the star was the width of this dot away 1 million times, so that's really far, even for just that little dot. So let's figure out another way we can interpret these numbers without having to lose our brain with all these zeros. So a second star is collinear with the first star. How many miles, the question is, how many miles is the second star from Earth? The second star from Earth is 1 million times, 1 million times 100 trillion miles away. So let's do this. We can do this a long way. Okay, 1 trillion, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 times 1 million. 1, 2, 3, 1, 2, 3. Okay, so when you learn how to multiply tens, you knew that if you multiply 10 times 10, the result would have the same number of zeros if you added them all together. So our number is going to be 1, and then the number of zeros altogether. So there's 14 zeros here, and then there are 6 zeros here. So there's going to be 20 of these zeros. 1, 2, 3, 4. Oh, actually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, let's put all these commas in here. This is a very impractical number to have to go by, but this is indeed this is the number, or 10 to the 20th. Okay, so that's how far our star is. But can we restate those terms in exponents? Right, 10 to the 14 times 10 to the 6 is equal to 10 to the 14 plus 6. So far, so good, right? 10 to the 14 plus 6. So how are the exponents related? So you would write in your notebook, can we restate the terms of the exponents? And you would write this part here, and then you would write how are the exponents related when we multiply with the same base. We add the exponents. This is a property that you've taken notes on and you've practiced many times up until now, exponents. We're going to do a little bit more discovery. I just have to pause really quick, so I'll be right back. Okay, so as you finished writing how are the exponents related, we added the exponents. So 14 plus 6 is equal to 20. Now let's talk about this in log form. And as a reminder, if you don't know this in your notes, log of x, when there's no base right here, it doesn't say a base, then when it says log, you assume that it's 10 down here, okay? So it says, what is the log base 10 of x? So log of 10 to the 14th, so we'd say 10 to what power is equal to 10 to the 14th. So this is what we practiced yesterday. Log 10 to the 10 to the 14th. You would think, you would do the swirl. 10 times what power is going to give us 10 to the 14th? And that's 14. Same with log of 610 to the 10 to the 6th. Do the swirl. 10 to what power is going to give us 10 to the 6th? And that is 6. And then together, log base 10. Even though I don't write base 10, default it is going to be 10. 10 to the 20th. What power of, oh, that should be 20. What power of 10 here is going to give us 10 to the 20th? And you would say 20. So there's some relationship going on here. Remember the exponents, 14 plus 6 is 20. And then we knew that the distance to from the star was, all the zeros were 14 zeros plus 6 zeros, so 10 to the 20th, which gave us 20 zeros. So we're starting to see a pattern here. In this case, can we restate an equivalent expression for total, the log, if we put them together, log 10 to the 14th. We know this answer. 10 to the 6th. We know this answer. If we multiplied this together, this would be 14 plus 6 would equal to 20. So let's see. Log of 10 to the 14th, right here, that's equal to 14. Oh, goodness. Log times log 10 to the 6th, which is equal to 6. Together, that is going to be 20. Because we know this is going to be log of 10 to the 20th. And then you're like, what is log base 10? You know you want to get to 20. Log base 10 times what power will give you 10 to the 20th? So now we know 14 plus 6 is 20. So catch up. Let me pause. Okay, so why is this equation true that we can just do like 14 plus 6? Let's rewrite the equation. The equation that's true is that we have log of 10 to the 14th times 10 to the 6th is equal to 20. We know this because log of 10 to the 14th plus, we can write this separately, log to the 10 to the 6th is equal to 20. Because log of 10 to the 14th, we found out, just like we were talking about up here, that's 14 plus 6, and then we know that's 20. So that's how it works. You may have some questions, so jot down some questions or hit rewind for a second just to listen to the last part again. Okay, so generalize to find an equivalent expression for integers m and n for the equation to be true. In this case, in your notes, you need to write, I would love if this would zoom out. Why is this equation true? In your notes, you can write, it's a general form. And now we're dealing with log properties. So log of 10 to the m times 10 to the n is also equal to log of 10 to the m plus n, which is also equal to log 10m plus log 10n, which is, in the end, going to just be m plus n. These are log properties. It may at first seem a little weird to use, but just like you once upon a time learned how to add, subtract, multiply, and divide, this is just another one of those skills that takes a lot of practice so that you can learn how to manipulate these. And it's always up for review. You can always ask to review logs. This general form is probably the most important part in your notes right now. This is where you can ask questions and work with your neighbor and your teacher to figure out this part here. But keep this result in mind as we progress through the lesson. Wait until after lesson 11 before you come in and start really asking for extra help, because we're going to do some more discovery. Okay, bye.